Do you know that 2 weeks from today will be the last day of school before Christmas break? Christmas break does go fast. I know. So we are embarking now on what would be the third unit for us. So I need to go back eventually and clean up some loose ends and give you a district assessment. It's just, like I said, I wasn't feeling like, it just felt right to just, let's get out of Dodge for a while today and go work on something else. So we'll go back and district assessment that absolute value unit. But as you saw, like from unit 1, the district assessment will generally be pretty straightforward, right? Shorter, like not a lot of questions, pretty bare level questions, just so the powers that be can make sure that you've learned the basics of what you have to learn. So we'll go back to that. So this kind of marks the start of unit 3. And we're going to do systems of equations. We in Algebra 2, like I told you a few minutes ago, we teach large systems of equations that are 3 by 3 is what we come to call them. That means there will be 3 equations with 3 variables. And so we're not going to solve anything like this today. So I'm just going to write this down. I'll write it like in purple, and you don't have to write it down if you don't want to. Just know this is where we're headed on Monday. So like you might see 4x minus y plus 2z equals -10, and x plus 2y minus 5z equals -40, and then -x plus 4z equals 12. So that's what we call a 3 by 3. It's got 3 variables. And the rule in math is that if you have a system of equations, the number of variables that you're attempting to solve for, you are required to have at least that many equations. So like what I'm trying to say is, like, you couldn't have 3 variables and 2 equations because you wouldn't have enough opportunities to weed out one of them to figure out what he is. So 3 by 3s are where we're headed on Monday. And honestly, if your basics are good, which, if you don't do little things like, oh, I forgot a negative, or, oh, 2 times 4 is 6, he, stuff like that. If we can avoid that, this next unit goes off without a hitch. It's just that it gets nightmarishly frustrating when you have a problem that takes 12 steps. And why did I miss this, Mr. Ahern? And then somewhere in the 7th step, you said -2 times 4 was 8. And that sucks. So it's easy if you're going to be meticulous and pay attention to the details. So today we're going to talk about 2 by 2s, because even though I taught all of you this in Algebra 1, it's good to get back to the mechanics of just how to eliminate rows or how to eliminate variables, so that when we go to eliminate in a larger scale, then we have the fundamentals down. So, and we will not be using any other methods. If you have a really good memory, you'll remember from Algebra 1, I taught you how to solve systems by graphing. I don't know why you'd remember that, but we graph a line, graph another line, and then look for the point where they cross. That's called the solution. Another way was to do what's called substitution. And that was the one where you get one of the variables by itself and then put a box and then plug the box back in. Like I said, 0 chance you'd probably remember that. The third method is the one that we use for these harder systems. And so it's the only one we're going to practice today. And so the method you're going to see in the instructions all the time, it's going to say to solve by elimination. And this is not the only way to solve systems, but it is far and away the most appropriate way to try to solve a larger scale system like a 3 by 3. And the jump, you might say, wow, now that I've learned a 3 by 3, let's try a 4 by 4. And you'll be amazed at how, like, the difficulty level, maybe that's not even the right word, like how the annoying level increases exponentially when you go from a 2 to a 3 and then a 3 to a 4. 4 is obnoxious. A 5 is like, whatever, like prepare to spend the next 7 hours, that kind of thing. So anyways, 3 by 3 is our focus. Elimination is our focus, but today is just 2 by 2. So let's get back to it. So here's an example of a system of equations. And I'm not going to give you any weird ones today that have like infinite solutions or no solutions. Everything today is just a simple XY ordered pair that solves the system. I will throw this 13-minute lesson at you in levels. So it will scaffold from easy peasy up to less easy peasy. I'm not going to say hard because it never gets difficult today. Okay. But this one is what I would have called, like when I had you the first time, I would have called this like a fluffer puffer. And the reason for that, do you remember that? Is because a system like this can be solved by just adding the equations together. So when we talk about this method called elimination, what we're doing is we're trying to add the equations together so that someone gets eliminated. And if someone is nice enough to write you a system like this is a self-eliminating system. I don't have to prep it. I don't have to do anything other than just add downwards. So if you add straight down the X column, what do you get? If you add straight down the Y column, what do you get? Exactly. So I can just bring down my equal sign. And if you add straight down the constant column, what do you get? And just like that, out pops a little sixth grade equation kind of thing where you divide both sides by 2, and you now know that X equals -1. So in like over here off to the side, I can now say to the world, hey, everyone, my answer is -1 something. Maybe this is already ringing some bells, even for you 10th and 11th graders. I don't know. 11th, you shouldn't be in 10th grade in here, but 11th graders, you may be starting to come back to you. Do you remember how we find the other one, the other number? You do. And the question logically here would be, well, where do you want me to put it back in? And the answer is, I really couldn't care less. You can pick any equation if in the problem, any that we're given, any that we create along the way, but it obviously has to have both variables in it, duh, because you have to put one in to solve for the other. So let's just say we picked the top one. So you just take the -1 since it's X and you put it in place of X, and then you do just a little bit of basic math. What is right here at the end of this arrow? What's -7 times -1? So that equation will now say 7 plus 5y equals 12, right? I just copied the equation, and then I take away the 7 and I get 5, and then I divide by 5 and I get 1. So the solution to this system is -1, 1. So in this context, what that means is that the lines represented by the white equations, because they are lines, they cross on the plane at the point -1, 1. Tomorrow, or not tomorrow, Monday, when we scale this up, we're going to be, we're not graphing, we're going to be talking about planes. So I'll show you a video on YouTube of what it looks like when 3 flat surfaces interact with each other in 3-dimensional space. There's lots of ways that they can interact with each other. But with lines, it's easy. Like everyone can figure out if you have a straight line and a straight line, they're either going to cross, sit on top of each other, or be parallel. Like there's literally nothing else they can do. But planes are way more exciting. So anyways, that's a simple example for you there. Now I'm going to buff up the difficulty just a little bit as we go through these. But it's like I said, you're never, today you just aren't going to struggle. It ain't going to happen. So here we have a system that is not quite a fluffer puffer, because if you were to just dive right in and say add the x's and then add the y's, nothing happens that we want to happen, right? I get -8x and I get 11y, and I'm like, I don't want that. That does me no good. The mission is to make someone go bye-bye. So how do we solve this dilemma? You can't. You just put, that's the moral of today's story is you just, if you want a number to be somewhere, put it there. You just have to put it there by multiplying the whole equation. So let's say I took the top equation and I multiplied it by -1. What that's going to do now is it's going to modify the top equation so that the number that I wanted to cancel with the -4x is going to be there. I'm not interested in the y's, right? I could have multiplied the bottom equation by -10. I think it's a little bit path of least resistance here. Like it's easier to multiply by -1. So what's the new top equation if I multiply by -1? Just like that. So now what we're going to do is we're going to let the top the red equation and the old bottom equation interact with each other, right? You can't reuse the one you just multiplied by in this. Like you have to use the new guy with the old guy, if that makes sense. So when you add downwards, how many x's do you get? Right, so they're gone. How many y's do you get? -9. And then what's 8 plus 28? And then divide by -9, and y is -4. So as far as writing the final answer over here, I can write blank, comma, -4, right? Is this coming back? Is this ringing all the bells? Hopefully, man, I hope so. Can't blame any algebra teacher other than myself if you don't know this. I guess Christian's the only one that I didn't have for algebra 1, but I assume you've learned this before. So, yeah. So again, how do we find x? Well, we plug it back in. And there are now 3 equations in play. So just for the record, you can use the original 1, the original 2, or the new guy, number 3. And any one of them is in play. Which one strikes you as the most delicious? The one that says 2 next to it? Yeah, I would agree, just because the numbers tend to be smaller. And at this point in your math life, halfway through algebra 2, you're probably not scared of a couple stupid negatives anymore, right? That was kind of a thing in like algebra 1 maybe, but now it's like, who cares? Just go for the small numbers. So if I rewrite the equation that has the little 2 next to it, it's going to say negative 4x minus 4, right? Because I changed the y into negative 4 equals 28. And then you solve. Add 4, you get 32. Divide by negative 4, you figure out that x is negative 8. So the solution to this one is the point negative 8, negative 4. Meaning if you graph those 2 lines, they'd cross down in quadrant 3 at the point that is left 8, down 4, way down there. So you know where this is headed. We're going to buff the difficulty again. So I gave you an easy route that time. This one I'm going to make it just a little bit harder. And then the last couple of examples will be sort of the top of the mountain, so to speak. 2x2 systems just don't get difficult. If you have decent mechanics, nothing to it. So what we got away with in the last problem was just changing a sign. Like Seth pointed out, we could just multiply by a -1 and presto, we have what we need. That isn't going to quite work here, right? And you have options. Like if Cooper wanted to kill the x's, pay attention now to the colored pen up here. If Cooper said, I hate x's, I have a thing for x. They badmouthed my dad one time and I hate x's. What would he want to turn this -2 into? Positive. He'd want to make it a +6. Could he? Of course he could. He could just multiply the whole top equation by -3. But then let's say someone else has a vendetta, a thing against y's, right? What could they turn this +1 into? A +2, so that it will kill the -2 above it. It doesn't matter in a case like this, like 6 of one, half dozen the other. Which one do you guys want to kill? The x's? Okay, so let's multiply the top equation by -3. You might say, well, what does it matter? No, it doesn't matter. Like it's all going to come out in the wash as long as you don't mess up. So if we multiply the top equation by -3, what will it now say? 54. Good, good, good. So again, I like to just, when I'm teaching this, I like to just put a little strike through in that just so you don't lose your focus. And it's going to get really bad with 3x3s. When you start to have, there's going to be like a whole page of work for like one problem. And it's really important that you kind of strike out things that you don't want to get distracted by. Like that. So add these equations together, what do you get? Yeah, those just cancel. So we get 7y equals divide by 7, y equals 6. Therefore, the final answer is blank, comma, 6. And then you put the 6 back wherever floats your boat. I would say that I feel pretty attracted to this equation. It just looks the most enticing to me. So I'm going to use that one. So I'm going to take the 6 and put it in place of the y. So the equation will now say -6x plus 6 equals -12. And then again, at this point in your life, I don't expect to see much work. I'm not saying you shouldn't. I'm just saying I'm not going to beat you up. So you subtract 6, get -18, right? Divide by -6, x equals 3. So stick a 3 in there, done. So what's the last part of this lesson? If you're paying attention, where do we go from here? What's the only way to step up the game? I mean, unless we add in like annoying fractions and stuff. What's the last level? We're not doing 3x3s today. Even if you want to, I won't let you. We're not doing it today, so take that. Yeah, good. Good job. Way to be in the moment there, Sutter. So the idea here is that now I can't just do something to one of the equations to fulfill my selfish needs. I like in all those previous examples, I could multiply just one of the equations by -1 or one of the equations by 3 or -3. There's no, and this is a lie. I mean, you could, if you were really good at fractions, you could multiply like the top equation by -8/3. But like really, no one in the history of the world has ever said, I want to do that, right? So what we think now is what Sutter said is I have to do something to both equations. And again, it comes down just to your basics. Quickly, what's something that 3 and 8 can both become? 24. Quickly, what's something that 7 and 10 can both become? 70. So it's just up to you. It's a matter of personal preference in a case like this of what do you want to kill? I think probably most people would kill the X's, right? Just because 24 is a little more palatable than 70.
What about multiply that top one
Say it again.
multiply the top one by 20?
By 20? Are you trying to kill these numbers over here? Oh yeah, don't do that. That won't do us any good. When we talk about elimination, we have to eliminate a variable, right? Yeah. Good. So what are we going to multiply top equation by? 8 or -8 is fine, but I'm going to go with 8 because I heard it first, which is fine. The bottom line is this, and this is the only place where people will struggle today. If it happens, it'll happen here. You recognize that the X's are both negatives, right? So at one point, one of them has to get switched. So if Corbin says, I want to multiply the top equation by 8, he is committed to saying top row is going to stay starting with a negative, which means he's cornered himself now into saying, I have to multiply the bottom one by -3. If Sutter wanted to multiply the top one by -8, that's great. He'll multiply the bottom one by +3. As long as you create that opposite stuff. So what's my new top equation? -24x plus 56y equals, good. And how about my new bottom equation?
44 or -30.
So, and if you make any mistakes today and feel frustrated, just know that that's going to be multiplied by 1,000,000,000,000 when we get to the big daddies. So use today, and I'm not saying like I won't make mistakes, but just use today to really work on trying to be as perfect as you can with every sign, every little thing, but it happens. So when we add them together now, the X's are obviously the ones that go kapooper. How many Y's do we get? Nope. We get positive 26 Y's. And then what's 8 minus 60? -52. Divide both sides by 26 and Y is -2. And I will also tell you that I had the computer make a worksheet for you today where all the answers are nice. So if you get things like, oh, it's a 7 divided by 2, you did something wrong. So that's kind of a guidepost for you. It's all smooth sailing here today. So if Y is -2, then you can put that like, right there. Huh? And then that equation will say -3x. What is that? -14 equals 1. Add 14, get 15, divide by -3. X is -5. So the answer is -5, -2. I want to do one more, and it's just for one very specific purpose. I'm guessing by this point you're like, we get it, but I want to just do one more so that I don't have to deal with this one number that everyone thinks means that the world is ending in a ball of fire. Yes. People get zeros and they're like, oh, is this no solution? Or it's like, oh, dang it, zero is just a number. So let's go through, and you already kind of know we're going to get a 0. So let's take a look at this one. There are times when zeros mean awesome, weird things. This is not one of them. I hope I'm thinking of I hope I got the right problem down. I feel really stupid if it doesn't have a 0. Whoops. Same thing as before. You can't single sweep this one, right? You got to say, I'm either turning you X's into 14s or I'm turning you Y's into 30s. Why are the X's more palatable? And it's not because the number 14 is smaller. Because there's already an opposite negative positive scenario. So I'm going to be drawn, if all things being equal, I'm going to pick the one where I don't have to mess with the signs. So I'm going X's because I'm the guy with the fake pen. So I'm going to multiply the top. Ooh, that's the wrong tool. tool. I'm going to multiply the top equation by 2 and the bottom equation by 7. Good. All right. So what's the new top equation going to say? Negative 14x plus 10y equals 30. Bottom? 7 times 18 is 70 plus 56. So that's 126. Still good? All right. Add these bad boys together. How many y's you get? 52, exactly. And then what's 30 plus 126? 150. I know, Cooper. I'm just wasn't there yet, buddy. And then I'm going to divide by 52, and I'm going to get, yes, y equals 3. Okay. So the answer, I didn't do this on the last problem. I kind of set a bad example. The answer is right here. It's there. Boom. You can even put a box around it and say, there it is. But remember, it's just not done. So give yourself maybe that place to put the next one. Put 3 back in. Which equation do you like bestest? Top OG, this one here? Sure thing. So it would say now negative 7x plus 5 times 3 is 15. And this is where people walk up to the desk. What I'm trying to do right now is avoid this awkward walk of shame where you realize that, oh, it's no big deal. When you subtract 15 from both sides, you get negative 7x equals 0. And I just don't, for the life of me, know. It's my fault, obviously, because I'm the algebra guy. Whatever it is I say that makes people think this is weird. This is no more special or different than dividing 21 by 7 or 15 by 3. It's just a number divided by a number. What is 0 divided by negative 7? Then the answer is that. It doesn't mean anything is coming to an end. It's just a number. Do you remember having troubles with zeros last year when we went through this? Swaggy B? Yeah. Not you. Someone in your class, I think. Does that ring any bells? Oh, it sure was. 0 was like the Antichrist or something. It was like, my God, it's not that bad. All right. Any questions? Your assignment, I did not photocopy today, and I honestly don't even know if I put it on Canvas yet. Whoops. But it'll be there in about 1 minute and 21 seconds. So stop the recording.